Hello, everybody, and welcome to this Microsoft Meets community event session. My name is Marius, and today I'll be talking about migrating traditional workloads to Windows Virtual Desktop and beyond. So essentially going through all the different steps involved to actually build the foundation, build Windows Virtual Desktop, and also build the different capabilities within Azure. So as I said, my name is Marius Sandbu, working as Guild Lead for Public Cloud for a company called Tietoevry, which is based out of the Nordics. So primarily working on public cloud initiative security and also end user computing aspect. So we're working within the IT industry now for close to 15 years, and the majority of that time I've been working on public cloud. And when I'm not working, I'm also heavily involved in different community activities, doing part of different user groups, conferences, and so on. And I'm also been fortunate enough to be awarded Microsoft MVP for Microsoft Azure. And I'm also doing a lot of content on my blog, which allows you to find link to here. So let's move to Windows Virtual Desktop. So of course, in most scenarios, you're coming from an existing VDI platform, either it being Citrix, VMware, or traditional Microsoft RDS, or you want to start with a brand new setup. But of course, in most scenarios, there's important steps that we need to make sure that it's done properly. Of course, we need to have a plan, make sure that we have the right competency, the right skill to actually build the solution. Of course, we also need to make sure that we have the required licenses in place. And of course, we need to do a proper assessment of the current VDI platform itself and also other dependencies for the VDI platform to work properly. And once we're done, we need to also build a foundation in Microsoft Azure. And of course, the foundation consists of a network architecture containing different security mechanisms in place, and also different governance policies and monitoring solutions, which I'll come back to in a later slide. And once the foundation is in place, then we can start building the Windows Virtual Desktop solution and also doing migration of the other workloads that we need to have in place to make sure the applications work properly. And of course, once that's done, then we can go over to the second-day operations to actually operate and manage this solution as a whole. So if we look at the first part, which is essentially understanding the state that we're coming from. Of course, we have an existing VDI solution that we've been using for many, many years. We have different monitoring and management tools in place that also is aimed at only managing that specific VDI platform. And of course, we have our different people working on operations and management of this specific VDI solution. And of course, moving from an existing VDI solution to Windows Virtual Desktop will also mean a lot of changes on the technology and the process that we have in place, but also the people actually managing it, because they need to have a new way of managing and operating this new solution. But as I also said, Windows Virtual Desktop is just a small part of the big picture. Of course, we also need to understand that, okay, what are end user requirements that we have, what kind of devices they have, working patterns. We need to understand different endpoints that they have. Are they AD based or Azure Active Directory based? Do they have thin clients? We need to understand what kind of workloads that we have. Of course, if it's more traditional office workers, or if we need to have a powerful GPU solution to actually power CAD-based applications. And we also need to understand what kind of supporting services that we need to have in place. Of course, we have file and print. A lot of VDI solutions also have built-in VPN functionality because there's always one application that needs to have VPN in place. And of course, we need to understand what kind of dependencies the different applications have, both if there's application service that we need to have, but also databases. So of course, these are some of the prerequisites that we need to have a good understanding of before we start to move to Windows Virtual Desktop. Of course, the last thing is also from a compliance perspective, because as it is of now, Windows Virtual Desktop stores metadata information. So regardless of where you set up VVD, it will store metadata information in one of Microsoft's data centers in the US. But this is going to be an option to set up in the West Europe data center, which will be a feature that is being rolled out Q1 next year. So once we have a plan in place, we need to understand the destination. So of course, there are two things that effectively affect the end user experience. One is, of course, the latency from the end user itself to the VDI service. And the second aspect is the application running on a VDI desktop and to other application dependencies, which might be databases or file servers. So of course, it is important that we don't build up a Windows Virtual Desktop solution without having all the dependencies or the data close to the applications. So of course, Microsoft, they have their own Virtual Desktop Experience Estimator tool, which is essentially a website that you can visit, which will monitor or calculate the latency from the end users to the closest Azure regions where the Windows Virtual Desktop control plane is hosted. Now, the last thing I want to mention is that moving to Windows Virtual Desktop and Microsoft Azure is essentially moving into a new ecosystem. There's a lot of different moving parts, and of course, just to highlight how much development that's happening on a yearly basis. Of course, last year, Microsoft alone had about 1,200 new changes, features that was released for Microsoft Azure, and of course, close to 1,000 changes on the Microsoft 365 ecosystem. And of course, if we look at the trends for the last 5 years, this progress is not slowing down. So we're going to see even a lot more changes happening on a yearly basis within these different platforms. So what do we need to have in place to actually start using Windows Virtual Desktop? Of course, we need to have the required licenses, either Microsoft 365 or Windows 10. Or if we want to use Windows Server, we need to have Windows Server RDS licenses. Of course, we need to have access to an Azure tenant, either a subscription using CSP or enterprise agreement or pay-as-you-go model. We need to have Azure Active Directory in place, which is then synchronized from an existing Active Directory. So we need to have Azure Active Directory Connect in place. And of course, we need to have a user that has permission to domain join virtual machines, has access to the subscription, either contributor or owner access, and also has access to the Azure Active Directory tenant. So as I said, moving from an existing VDI solution to Windows Virtual Desktop is going to introduce a lot of new changes. And of course, within Azure, you have a lot of different options to choose from. You can either use the Azure built-in functionality, such as Azure Firewall, to actually provide firewall functionality for your foundation or your network topology. Or you can also use different third-party appliances which are supported for running in Azure. So what I want to highlight with this slide that there's a lot of options to choose from. We can either use the Azure native functionalities, or we can continue to use any third-party providers that are supported. So let's take a look at the Windows Virtual Desktop ecosystem. So of course, we have all these different services and supporting services within Azure that we can use. Of course, from a provisioning perspective, we want to set up VVD. We can either use ARM templates, we can use PowerShell. There's a lot of different examples on GitHub already, or we can use Terraform, which is an example I'm going to show afterwards. But all these different CLI API-based tools will run through Azure Resource Manager, which is the underlying automation framework or underlying orchestration layer in Azure. So when we set up a Windows Virtual Desktop workspace, which consists of a lot of different components, which Microsoft would manage for us. But if we also take a look at the connection flow, so from an end user, when they set up a session to a VVD desktop, it will go through a service in Azure called Azure Front Door, which uses TCP Anycast. And therefore the user will be routed to the closest Azure region available, and then the traffic will go through Microsoft's core network or core backbone to where the VVD instance is hosted. Either it's in Norway or in West Europe or in Asia. So from an infrastructure perspective, we also have different options to choose from when it comes to storage, when it comes to instances powered with GPUs, when it comes to hybrid connectivity to connect our existing on-premises data center to Microsoft Azure. We can also integrate different platform services into the existing virtual network using private link. We can also have different supporting tools to actually manage and operate the environment itself. And one example I want to mention there is using Azure Automation with Update Management, which allows us to automate the installation of Microsoft patches into your VDI desktops. And of course, we also have Log Analytics, which is essentially a log aggregation service which can collect logs from all the different services and within Azure, but also virtual machines, which can then also be enhanced using Azure Sentinel, which I'll come back to also in a later slide. And of course, there are some limitations that you need to be aware of before you start using or start building Windows Virtual Desktop, depending on what kind of supporting services you might be using, but also some limitations that are on a subscription level and also on what kind of Azure region you want to be building your Windows Virtual Desktop setup. So I will go through some of these limitations. So if we start looking at the Azure subscription, where we have soft quotas in place for the amount of vCPUs that we can access. So if we have a project ahead, we need to go through a support ticket within the Azure portal and define how many virtual machines and how many vCPU cores that we need to have. So of course, we have encountered in some scenarios where specific regions doesn't have enough capacity available, and they will give us an indication that we need to wait 1 to 3 or 6 months before they have the required capacity in place. And the second one I want to mention is regards to Azure regions. And not all Azure regions are the same. There's a lot of difference between what kind of services that are available within the different regions, what kind of hardware that's available. So of course, if you have an upcoming project that will span across multiple Azure regions, make sure that the services that you need to have are available in those specific regions. And specifically when we see that Microsoft is setting up new data centers where features are rolled out within different waves. So it might take some time before the different supporting services that you might need are available within that specific region. There are, of course, other limitations that you need to be aware of. The next one here, I wouldn't call a limitation, but something that's important to consider. So Microsoft recently introduced a new feature called VVD Short Path, which allows an end user device to have direct connectivity to a VDI desktop using a UDP-based protocol. So of course, the only way a client can access directly a VDI desktop either is that the VDI has public IP address, which we don't want to use because of security. The other option is to go through a VPN service, either use the VPN gateway or express route, or that you have clients that use point-to-site VPN. So of course, if you want to use the last option, it is important that you use a VPN protocol which also uses UDP, such as IKV2 or the OpenVPN protocol in Azure. So protocols such as SSTP uses TCP based, which will generate a lot of overhead if you try to push UDP traffic through a TCP protocol. The second one I want to mention is that if you want to use third-party firewall providers or third-party network devices within Azure, a lot of those devices, they use layer 2 protocol functionality such as reverse ARP or gARP for high availability and failover. And of course, that protocol or the use of reverse ARP is not supported in Azure, but of course in most scenarios, most scenarios that I've encountered at least, all of those third-party providers, they have different deployment guides to actually set up high availability for their specific service within Azure. So now we come to the virtual infrastructure. Essentially, what kind of virtual machine types do we want to use to power our VDI desktops? Of course, within Azure, there are different t-shirt sizes that we can choose from depending on what kind of workload or CPU to RAM ratio that we want to have. Of course, Microsoft, they have specific recommendations on what kind of CPU or what kind of virtual machine instances you should be using. And I think it was during the summer, either July or August, that Microsoft started rolling out the new AMD-based version 4, generation 4 instant types, which I see, if we compare it to their older version, is a little bit cheaper, but also has a lot more powerful processor compared to the older Intel ones. And of course, if you want to have a GPU-based workload, essentially two options to choose from, either NVIDIA-based, either with the M60 graphic cards, which are part of NV6 or NVV3 series, or we have the NVV4, which is powered by AMD GPUs. Of course, there are a little bit difference in terms of supported operating system and how much available graphic memory you get allocated to the VM. But of course, the most important aspect is that you have the letter S in the instance type, because that indicates that it supports premium-based storage. And of course, one important consideration is that if you are planning to have any type of SQL server or Active Directory service running within Azure, remember that you turn off this caching, read or write caching mechanisms that is enabled on virtual machine hard disks, because what we've seen in other projects and several other cases is that the read-write cache might corrupt data. So it's a general best practice that you turn off caching for any database-related workload. Now we come to the final tips when it comes to sizing of the environment. So first thing I want to highlight is when it comes to FS Logics, which will in most scenarios be hosted on Azure Files. So FS Logic will be using Azure Files to store the profile disks. So of course you need to plan how much IOPS and storage we might need to have to handle the amount of users and depending on the workload. So here I want to highlight one of the VVD gurus in the community, so Ryan Manigan, which has created a spreadsheet, which is available on GitHub, which essentially you fill in the amount of users that you need, storage disk size, and what kind of workload, and you'll get a calculation on what kind of IOPS you would need to actually handle that specific load. When it comes to VPN, as I also mentioned, for short path functionality, it's important to understand that the different types of point-to-site VPN connectivity has different support when it comes to active connections. So it can range from 128 active sessions to 10,000 active sessions. And of course, the second aspect is the VPN gateway itself. So if you're not using ExpressRoute, you will have a specific amount of throughput available for the VPN gateway, which of course will be shared between the site-to-site and the point-to-site connections that you might have. And the final aspect is if you are using Azure Firewall or any type of third-party application or third-party provider, or you're using the NAT gateway functionality in Azure, so you need to make a calculation for port exhaustion, so meaning that there's only so many that can share a single public IP address for outgoing traffic. So just to give an example, Outlook alone can use up to 8 outbound ports. So if you, of course, have a VDI platform which is running Microsoft 365 and also other applications which require outbound connectivity, then you need to make sure that you have enough public IP addresses which the VDI platform can use to connect outbound. Of course, if you are running a VDI platform alone, the rule of thumb is generally that you can have about 6,000 VDI sessions or 6,000 users running on a single public IP address. But of course, if you have an Azure environment which consists of multiple different services which need to have outbound connectivity well, make sure that you have more public IPs available. So now we have a plan. We understand how Windows Virtual Desktop works, what kind of supporting services that we have in place, and also what kind of limitations that you need to be aware of. So now we're in the assessment phase of understanding the current environment that we plan to migrate out to Microsoft Azure. Of course, in most projects, the first thing is to look at the documentation to figure out what kind of dependencies the specific applications have. But of course, what I've learned to understand is that most of us are not good at documentation. But of course, there are tools in place that can help us do this type of assessment. Of course, I'm going to be focusing on using Azure Migrate, which is a native service in Azure, which allows us to not just assess the current environment, but also do migration. And of course, Microsoft has also entered into partnership with Lakeside to actually do VDI environment assessment as well. But it's of course important to understand what kind of integrations that we have between applications running on a VDI desktop with other third parties, other application services or servers or even database services, but also understanding the requirements that those applications have from a I/O perspective and also from a CPU memory perspective. And also getting a baseline for today's end user experience. So what kind of latency they have today, how much time do they have to wait for actually log on to the service. So using that as a baseline when we're starting to build this new service. So of course, when it comes to actually doing the assessment of the current environment, Microsoft, as I said, has a service called Azure Migrate, which is a service combined with a local appliance, which is going to be connected to your existing environment. So essentially, there's two ways to deploy Azure Migrate. It's either agentless. So essentially, you have an appliance which connects to vCenter in this example, and using the vCenter APIs to communicate with different virtual machines. Or you can also do agent-based, essentially installing an agent on each virtual machine, which then communicates back to the Azure Migrate service to actually give information about the current environment. But of course, both agentless and agent-based are different supported options when it also comes to migration or replication of the virtual machines. And to do the assessment, Azure Migrate collects a lot of information from the virtual machine, so CPU, memory, disk usage, information about the VM itself, so what kind of operating system is running, and also collects application-specific data as well to actually understand what kind of roles and features are being run or used on this VM, also what kind of applications are installed, and they also collect a lot of information about network connections as well. So all this information is being uploaded to Azure Migrate, which is essentially using log analytics to store the data. So as part of your assessment, Azure Migrate will give us recommendations on what kind of VM sizes that we should use for our existing machines. So as I said, it looks into supported applications or protocols, but I have seen in some cases that it doesn't understand if a VM is using a specific layer 2 protocol, which is first not supported in Azure. The migrate assessment will also give us information about if there's machines that are not ready to migrate to Microsoft Azure. So there are some black box solutions, so appliances from Cisco, F5, or Citrix, which might not be directly supported to run in Azure. So these are the ones that you need to be aware of and understand what kind of options that you have. And also Microsoft has a list of supported server software which can be run in Azure, which is located on the link here. And some services can be lifted to running platform as a service, or migrating from a virtual machine to a platform service in Azure to save costs, save management. But if it's a third-party application, you need to get support from that specific vendor who can actually do that lift. Because I have encountered scenarios where we have lifted from infrastructure-based service to a SQL database in Azure, but was not supported from that vendor. So as I said, Azure Migrate uses log analytics to collect data. And of course, log analytics is used for a lot of different purposes in Azure. Of course, all the different services within Azure can have a diagnostic settings enabled and send logs to a central log analytics workspace, which is essentially a database, which of course has different tables depending on what kind of data that's being collected. And of course, we have Azure Sentinel, which is an add-on to log analytics to actually provide threat detection or CM-based service on top. And we can also have Azure Monitor, which also stores data into log analytics, which allows us to provide more monitoring-based rules. But against the data that's being stored into log analytics, we can run something called Kusto queries, which allows us to analyze all the data that's being collected. So Microsoft also has a lot of different add-ons or modules to log analytics to provide a lot better, richer visualization of the data that's being collected. And as part of Azure Migrate, we have a service or a module called Service Map, which essentially shows the different integrations and the VM or the connectivity between a virtual machine and other network resources. So here's an example of running service map. We're essentially looking through the data and shows, okay, this specific VM has a lot of outbound connections that I need to be aware of before I actually start to migrate this virtual machine out to Azure. So as I said, we can run Kusto queries directly at the data that's being collected. Log analytics uses a lot of different tables depending on what kind of data source that's being collected. We can run Kusto queries which are read-only against that data. So this is an example where I'm looking at the VM connection table which is being collected by the service map module. Looking back the last 9 days, I can specify a computer name if I want to filter on a specific VM. I want to exclude some specific ports that I'm not interested in getting as part of the data result. And then I can get a list of which process that is running on this VM, what kind of remote IP and destination that the VM or the process is communicating with. So that I need to make sure that when I create my foundation that I have firewall rules in place to allow this specific traffic, or if I want to notify any third parties about new IP addresses that will be used to communicate with that specific IP address. But of course, everything starts with a foundation. So foundation is a set of architectural principles and guidelines that we need to have in place before we actually start building and migrating services out to Azure. So foundation typically consists of the way we organize our subscription and management groups, how the network should be organized, and how connectivity should be between Azure and their on-premises data center, what kind of security and governance functionality we would have in place, monitoring, how we get access to the environment, both from an end user but also from an administrator access, and other supporting services that we would need to have in place to make sure this is a fully functional environment. So of course, this picture that I have here is part of the Azure well architected framework, which is essentially a set of guidelines and principles that you can use as a starting point to actually build your environment. So these were updated and released now during the summer. There's been a lot of updates since with new functionality, new features. But of course, this is not a one-size-fits-all model, so it's important that you use the principles and start building your own framework. Microsoft also has prepared a preset of automated foundation deployments, either using Terraform or ARM-based templates. You can also use the Azure Security Benchmark, which also gives you a list of best practices when it comes to security for Azure-based environments. And then there's also different best practices when it comes to deployment of Windows Virtual Desktop and FSLogix. As for Windows Virtual Desktop, there's only a few prerequisites that we need to have in place. We need to have a virtual network. We need to have Active Directory set up synchronized with Azure Active Directory, so using Azure AD Connect. We need to have a virtual network that is configured so the DNS points to the domain controllers, so that way when we deploy Windows Virtual Desktop host pools, they're able to communicate with the domain controllers and join themselves to the domain. And the final aspect is actually building the Windows Virtual Desktop components. So when it comes to building Windows Virtual Desktop, you can of course deploy the components through the portal, or you can use one of the automation frameworks that are available. Of course, here I'm going to be focusing on using Terraform, since they introduced support for Windows Virtual Desktop as part of the one of the latest releases that came out a couple of months ago. Another component which also will be used to actually build the actual image, so the golden image itself. Now, Microsoft recommends that you use something called Azure Image Builder, which is a new service Microsoft is rolling out, but is based upon an open source product called HashiCorp Packer. So of course, if you look at using these different tools to actually deploy the entire environment using a DevOps-based framework, you can essentially use Terraform to build the foundation, building the network structure, building the Active Directory components, and other supporting services that you might need, and also deploy the Windows Virtual Desktop components. And then you would have another DevOps pipeline to actually build the golden image using Packer and configuration files, and then use Terraform to deploy host pools based upon the image that Packer has been creating. So if we start by looking at the different components that we can deploy using Terraform. So Terraform as a configuration language uses its own syntax. So we define what kind of resource that we want to provision and all the different requirements that we have. So with Windows Virtual Desktop, there are essentially four resources that we can deploy. It's the workspace, which needs, of course, to be defined as US because of the metadata. We deploy the host pool, where we also need to define the registration info. That way we have the token that we use to actually associate the host pools with the workspace. And then we have the different application groups and association between the application group and the workspace. And then we of course have building the actual golden image, which can be done using Azure Image Builder or using Packer. As part of the example I'm going to show afterwards, we'll be using Azure Files, which will be mounted during the build of the image itself to install any application or other dependencies that we need to have inside the image. Of course, we need to follow Microsoft's guidelines here in terms of their recommendations when it comes to building an image. Within Packer, we also have the concept of something called provisioners, and that is something that is done during the build of the image itself. So there are some different supported provisioners that are, of course, documented. The two examples I want to highlight here is either PowerShell or the file provisioner, which essentially uploads a file or content from it, from where the provisioning is happening into the VM that's being built. And of course, we need to define what kind of VM template that we want to use in Azure when we're using Packer. So the table on the right-hand side shows the different VM image types that we have available for Windows Virtual Desktop, for Windows 10 multi-user, and for Windows Server. So when we're done creating a Packer configuration file, which is JSON based, we should always run the validate command to make sure that the JSON is correct before we actually run the build. And the final aspect is building host pools based upon the golden image that we built using the registration token to register the VDIs to the host pools. Of course, this should be an automated process, and luckily our colleague of mine has written a blog post which showcases how we can use DevOps pipelines to actually automate this entire process. Microsoft has also created optimization scripts which are built for the different Windows 10 versions that are out there. These are of course available on GitHub, and what essentially does is it uses a component within the security compliance toolkit called LGPO, which injects all the policies into the local group policy configuration of the image itself. Just make sure that you look at the README file before you use any of these policies, because there are some important issues that are listed depending on which of the Windows 10 versions you plan to run. So now we've built the foundation, we've set a Windows Virtual Desktop, and now we need to make sure that the environment is fully functional and making ready for the migration of the remaining workloads. So if you are, for instance, using Azure Firewall, there are predefined rule sets that we can use for Windows Virtual Desktop purposes. And there's also a troubleshooting query on the right-hand side. This is a Kusto query against the Azure Firewall data that's being collected into the Azure Diagnostics pane. So essentially looking into deny actions, so you can go through and see if there's any specific traffic that should be allowed. And of course, if you already have domain controllers, if you plan to build new domain controllers as part of the foundation before you migrate remaining workloads, make sure that you have some form of availability feature that you're using for them, either using availability zones or using availability sets. And then, of course, we need to make sure that we have move groups defined. So essentially, what kind of workloads should be migrated together. Of course, if you have applications that are dependent on a database or file server, these should be moved together to make sure that you get low latency as possible once the workload is migrated into Azure. So when you're doing the migration, so actually using Azure Migrate to replicate and fail over virtual machines into Azure, you need to have a playbook. So a playbook essentially defines different tasks you need to do, from testing a VM, testing the dependencies, and actually starting and setting up the virtual machine in Azure in the production environment. So if you look at the first step, essentially failover testing, which means that the workload is still running on premises, but we're replicating the VM to Azure, and we start the VM using the test migration feature in Azure Migrate into an isolated virtual network. So of course, this is done because we need to make sure that the VM will actually boot in Azure, verify disk and applications that are running in services, and also document what kind of steps that need to be taken to make sure that the application and any type of application dependencies will run on the VM itself. So once that's done, we documented the steps, then we do the actual failover. And then we fail over a set of virtual machines as defined within the move group that we have. So we're shutting down the VMs on premises. We're doing the failover using Azure Migrate into the production virtual network. And then, of course, there are different steps involved to make sure that we test network connectivity, dependencies to other applications that we have, and integrations. And then we'll, of course, have the application and system owners, which can go in and verify that the application system is fully functional. And then we go live. And of course, this is something that we repeat for each move group that we have to make sure that it's fully functional. Of course, this is a pretty simplified playbook. Microsoft has pretty outlined descriptions if you look into the Azure Migrate documentation site in terms of other steps that should be involved depending on the size of your environment. So now we've done the migration of the workloads and we enter into the operational phase. So how do we actually manage and operate an Azure-based environment with Windows Virtual Desktop? So one important aspect is log analytics. As I said, essentially a database that collects logs from all the different services in Azure. So you have to go in and enable diagnostics on a workspace level, so we can get information about management, so what changes that we're making to the environment, what kind of errors that is occurring. And of course, this can also collect information from not just the service itself, but also the virtual machines running in Azure. Now, since log analytics is essentially a database and you define the retention on the workspace level, but you might be storing a lot of different data within the workspace. So it might be performance related data, but also be diagnostic settings such as this one on the right-hand side. But you can define retention on a table-based level, but it's not available in the UI, so you have to use REST API to actually change the retention on what kind of table you want to have storing for a longer period of time or shorter period of time. So I've added a link to my blog post where I actually showcase how you can use this. And of course, another aspect which has also been introduced for not so long ago is now you can do export of data from log analytics to an external CM-based tool. So it might be that you have an existing solution using Splunk or Curator or something else where you also want to collect the same data. Now you can define what kind of tables should be exported directly from log analytics workspace to an external third-party CM tool. But of course, this just collects the logs and information. We also need to have some form of dashboard to actually monitor the current state of the environment. Of course, within Azure, you have something called a concept of workbooks, which is essentially predefined queries against the data that's being collected into Azure Monitor, and also uses another API called Azure Resource Graph, which essentially aggregates what kind of services or resources that we have within Azure. Microsoft also has a predefined Azure Monitor workbook for Windows Virtual Desktop, which looks something like this. So we can get an overview of what kind of host pools, how many connections that you have. So this is essentially collecting or visualizing the data that's being collected into the log analytics workspace. And of course, the final aspect is defining alert rules. And within Azure Monitor, we have the concept of something called service health, which allows us to get information when Microsoft has planned or unplanned maintenance on Azure. So we can define which service that we want to get notified about or what kind of regions that we want to get notified about. So of course, this should always be specific for the regions that you plan to use. Of course, alert rules for service health is one thing, but we can also define different alerting rules in Azure for all the different data that's being collected into log analytics. And to actually get notification or to create an action, so when a certain event occurs, we want the following action to be taken. So within action groups, we can also define who should get notified, so we can set up an email notification, we can use a webhook to get notified on Slack or Teams, or we can also define a specific action to be run. So this could be an Azure function or an Azure automation workflow that can actually restart a server or restart a service if the specific alert occurred. What we have also seen from time to time is that Microsoft might be a bit slow to actually get information out there. So it's always useful to use members of the community to actually figure out if there's something weird going on with Azure at any given time, because we have seen scenarios where Azure services went down, which actually also took down the status page, so we didn't actually see what was going on. So when it comes to the day-to-day operations, there's of course a lot of third-party vendors now that are building management capabilities to enhance VVD. But of course, I want to highlight one specific tool that has been created by one of my fellow MVPs in the community, which has created a really great, really simple user interface to actually enhance the built-in functionality in VVD. So of course, it does everything from deploying host pools, deploying application groups, and also publishing applications. And it can also get information about user sessions that you have active. And then, of course, there are some final things I want to mention. As I said, the Microsoft Azure and Microsoft 365 is ever-changing ecosystem, so there's going to be a lot of changes happening almost on a daily basis. And of course, a lot of new functionality is now currently in preview as well. So support for Defender ADP for multi-user and also Intune support also in preview. I also know there's a session later today talking specifically about management of Windows Virtual Desktop using Intune. I also want you to take a look at the roadmap and also the latest changes that have been happening on VVD to actually see if there's new functionality, new features that can enhance your end user experience or improve security overall. So if there are specific details here that you missed out, or if you want to get more of the overview perspective of everything that I've covered as part of this webinar, I've actually pre-created a blog post which will be available in this link here, which actually goes through all of these different steps in detail. So with that, I want to thank everyone for tuning in and listening to this session. If you have any specific questions or comments, feel free also to reach out to me on email, social media, and hopefully you'll also stay for the other great sessions that are later today. So with that, thank you and enjoy the rest of the day.